Okay, welcome. It's a series in which I will practice maths. Why I'm practicing maths? Because my work is related, doing a lot of calculations, and every now and then, because I haven't practiced my maths skill, I get stuck. I don't want to get stuck anymore. I waste a lot of time because of it. So my plan is to practice maths problems from college level up to university level that will r- that will refamiliarize me with the basics operations of the maths that we used to do when we were regular students. So this video is going to be raw, unedited, and after a few tries, after checking the quality and everything, I will start editing those videos before uploading. So now let's get started. Oh yeah, let me show you the book I'm using. I'm using a book, good old book, College Algebra by Jerome Kaufman. This one. Okay. So I'm using this book. I have the hard copy. Okay. I'm gonna start with the exercise or chapter 1.5. First, doing the examples. Why I'm going directly to 1.5? Because everything before was pretty basic and we all know those things, so I don't need to repeat those. In any ways, we will learn as we practice these problems the basics as well, so no need to reading those chapters or working on those chapters. So let's start with the first example. Example 1 of 1.5, called rational expressions. So it has a problem: x plus 4 divided by 4 plus 3x plus 1 divided by 3. Now the first thing we need to do is find LCM. How do we find LCM? It's pretty simple. On the right side I will do my rough work. So we will put these two numbers here and we will start with the lowest integer, not 1, because 1 can do pretty much divide, is a factor of every integer, so we don't need that, and we cannot do anything with it. So let's start with 2. It is not a divisor of 3, and it divides 4 by 2. Again 2, we get 1. Now we will start with 3 and we get 1 1 in the end. So to calculate LCM, all we have to do is multiply all these numbers. 2 multiplied by 2 multiplied by 3, which is 4 multiplied by 3, which is 12. So now we're going to replace 12 here. So how to fill the remaining equations? What we do here, oh, this is very colorful pencil, so I'm gonna learn this Microsoft whiteboard as we work on the problems. We divide 12 by 4 and then multiply the item, whatever we get, to the denominator, to the numerator over here. So 12 divided by 4 is 3, so we get 3x plus 4. This plus comes like this. Now 12 divided by 3 is 4, and it's gonna multiply with this expression. Moving on, this 12 will remain as such. Now we multiply this 3 with all the terms inside. Let me switch off my monitor. Okay, there you go. I'm working on my tablet right now. So 3x plus 12, similarly plus 12x plus 4, not 1. So now we add these similar terms. 12 15x plus wait a minute, where did I, oh, okay, I did a boo-boo. Anyways, it was 2 in the original, but I wrote 12, I wrote 4 over here. This was 2. Anyways, we can move on and work on it. It's gonna be 16. That's gonna be 12. This is going to be our answer. Moving on. Moving on to example number 2. This time around I will try my best to write the question at least correctly. I always do that. I always lost a lot of numbers because I didn't copy the question right on my answer papers. So 2x plus 1 divided by 15 and minus x minus 2 divided by 18. Let me check again. Did I copy it right? Yeah, it seems alright. So the first thing to do, not in order, is to find LCM of the denominators. It's going to be 10, 15 and 18. We will do the same procedure as we did before. We divide it by the lowest number, 2. Yeah, it's going to be 5. 15 doesn't divide by 2. It's going to be 15 again, and it's going to be 9. Now, does 2 divide anything else? No, so we will go to 3. Yes, 3 does divide everything, or 2 terms at least. It's going to be 5, and it's going to be 3, and we 3 again, and we have, right, and now 1. Now we have 5. It's going to be 1 and 1 and 1. So what's going to be LCM? It's going to be 2 multiplied by 3 multiplied by 3 multiplied by 5. Right. So that's going to be, these two going to be 10 multiplied by 9, which is going to be 90. So over here we will write 90. We'll do the same operation. 90 divided by 10 is 9. 9 is going to be multiplied by the terms here. This plus comes here. Okay. 90 divided by 15. Oh, I'm not so good at maths. I think it's 6. 6. Let me check on my phone. 90 divided by 15. It's 6. Yes, it's 6. It's 6. So it's going to be 6 into 2x plus 1 minus, this minus comes here. Okay, 90 divided by, we're going to do a calculator here, right? C and C, I'm not that good, so I'm going to use calculator. Okay, what did I have to do? Okay, 90 divided by 18. It's going to be 5. So 5 multiplied by x minus 2. Okay, it's going to be 90, 9x plus 27 plus 12x plus 6 minus 5x minus 10. Alright, if we do all the calculations, alright, it's going to be 90 by 16x plus 43, and This is our answer. Moving on to example number 3. I need to stop writing the full word example. It takes a lot of time. The question says add 3 over 2x plus 5 over 3y. Did I copy it right? Yeah, copy it right. Now, to find LCM, we have to understand this one thing. The variable parts, which are x and y, we will take the highest polynomial of them. Right? So let's go again. We have 2 and 3. The LCM is going to be 2 is equal to 1, and it's going to be 3, and this is going to be 3 again, and it's going to be 1. So LCM is going to be 2 and 3, which is going to be 6 on the integer side. But now there are 2 variables. What to do with them? Because there is only one x and there is only one y, we have to include those. So the LCM by default will have it's supposed to be 6, which we calculated already. It's going to be 6 and xy. Suppose if this was 2x squared plus 5 3y plus 6x, we would have selected only x squared and y. We will select the variable with the highest polynomial. It will represent the both of them. That's the law, that's the rule, not the law, rule. Okay, so we're going to do that. So I did similarly. So the power 1 with the highest polynomial, so I selected both. So what happens if I divide this by 2x, it's gonna be x is gonna cancel, it's gonna be 3, and it's gonna be 3y into 3 plus it's gonna be 2x into 5. Right? So what's gonna happen? It's gonna be 9y plus 10x divided by 6xy, and this is our answer, ladies and gentlemen. Moving on, let's go to example number 4. I mentioned earlier that I wouldn't write the whole word example. I still wrote it. It says subtract 7 divided by 12 AB minus 11 divided by 15A squared. Now this is interesting. So for the integers, we're going to take the LCM the old-fashioned way that we discussed. We're going to write 12 and we're going to write 15. So it's going to be 2, 6, and 15. 2 divide 6 and we get 3 and 15. Now we will move to 3. 3 is greater than 5. Now we will move to 5 again. It's going to be 1 and 1. Right? So LCM is going to be 4 into 3 into 5. It's going to be 12 into 5, which is going to be is equal to 10, 1, 1, 16. Right? Am I right? Yeah, I'm right. So in denominator, we are sure we will have 160. Now we need to pick a variable to represent each kind of variable. Now this one is a square, this one is a, so we pick the highest polynomial one, which is a square. Coming to b, we have only one b and we will select that b. This is going to be your LCM in the denominator. Now divide this term from here. So what we get, 60 divided by 12. I'm not that good. Let's find the algorithm. 60 divided by 12 is going to be 5. So I'm pretty sure this place is gonna have 5, right? Both A will cancel. We will have at least one A. B will get cancelled, and there will be no B. So multiply by 7 minus. Now we will do 60 divided by 15. As usual, I'm not good at maths, so it's gonna be 60 divided by 15. It's gonna be 4. So I'm sure there's gonna be 4 above. Right? And I'm sure there's gonna be B above, because the A square cancels out and we were left with B. This is gonna be multiplied with 11. So let's do that. It's gonna be 44B, 60A squared B, and 7 divided by 30 is gonna be 35, I think. It's gonna be 35, yeah. 35A. 35A. Oh, let me fix that. It doesn't look good. 35A, and this minus will be here. And ladies and gentlemen, this is our answer. Seems pretty straightforward till now. Okay, going to example number. Oh, okay, this time around I'm not going to write the complete word example. Oh yeah. Oh, this is a nice one. Example. Ever this happened to you that you look to a problem and you say, oh yeah, I like this one. Yeah, it's same for me. I like this equation. X squared minus 4x. Oh yeah, I like this one. Plus 2x. Is it minus? So first thing to do when we have an equation that can be factorized or that can be simplified further, you should do that. So how do we simplify this equation? If we take x common, it's going to be x minus 4. So what will happen here? It's going to be x minus 4 plus 2x and 8. Now in the denominator we have to have an LCM. So how do you take LCM of variables? You check this. We represent all the variables with highest polynomial. X with power 1, yeah, x with power 1. Okay, I'm going to change it, x with power 1. And we have to include this term as well. It's going to be 1. So we will have this denominator as LCM. So now this term divided by this is 1, so 8 into 1, and this is gonna be 2 plus the x cancels each other out, and x minus 4. So we will get 8 plus 2x minus 8 divided by x minus 4. Right? So these x's cancel each other out, so we get 2x divided by x minus 4. Is this the answer? No. We can simplify it further by deleting these two x, so we got x minus 4, and this is our answer. I think I need to enhance shape though. Okay, let's switch off. It still works enhancing the shape, I think. Anyways, we're done here. We'll move on. What time is it? Okay, it's only 15 minutes, so Go. How much examples we have to go? Oh yeah, we have 10 examples. I think we have ample time. Oh, I'm not going to write it complete. Number 6, it says add 3n divided by n squared plus 6 plus, no, okay, plus, yeah, plus x plus 5 plus 4 n squared minus 7n minus 8. So what did I said before in previous example? We need to simplify our denominators. We can simplify these two terms. So let's start with the first term, x squared plus 6x plus 5. How to simplify it? What two terms that we multiply gives 5, and when we add gives 6? It's gonna be 5x plus 1. No x's. 5x's and 1. My bad. So we're gonna write that 6x plus 5x plus x plus 5. So we take common x as common here, x plus 5 and plus 1, x plus 5. So we have x plus 5 and x plus 1 is going to be 1 denominator, right? Now we will solve the other one. X squared minus 7x minus 8. What two numbers when we multiply gives minus 8 and when we add gives minus 7? It's gonna be minus 8 into 1. When we multiply gives us minus 8. When we add give minus 7. So we're gonna solve for that. X squared minus 8x plus 1x minus 8. X we take common, x minus 8 plus 1 we take common, x minus 8. Yeah, x minus 8 and x plus 1. Now the trick is to include every term, right? So we will draw the denominator line. We will have x plus 1, this one. We will not repeat the same term. We have this thing common. Now we have x plus 5 as common, right? And we have x minus 8 as common. Now it's pretty easy. When we multiply this term, divide rather, here, what we get, these two terms will cancel out, x plus 1, x plus 1, and we will be left with x minus 8, right? So it's gonna be 3x into x minus 8, right? These are multiplication, and this plus comes in as plus, like it is. So the next term, next thing that we need to do is divide this term here. This is x minus 8, and this will be removed from this, and we will be left with 4 into x plus 5. Right? Now all we have to do is multiply. It's gonna be 3x squared minus, what's 8 multiplied by 3? God, I'm so lame. 24 plus 4x plus 20, right? And in the denominator we have x plus 1, x plus 5, x minus 8. We have to simplify this polynomial, so it's gonna be x plus 1, x plus 5, x minus 8, and if we do the addition, it's gonna be 3x squared minus 4. No, 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 minus 24, 24x, right? Yeah, like I said, I do a lot of issues. I'm not that thorough. X plus 20. Good God, I'm so bad even with the examples which are supposed to be easy. This is our answer. So moving on, or maybe it's my my first lecture online. I'm nervous. Oh God, oh God, I hate those. I hate these type of questions. So another example. Oh, I'm writing it again. It says simplify phi. Holy shit. 3x plus 2y. Oh, it's gonna go crazy now. And 5 over x minus 6 over y squared. Trick over here is to remember what's in denominator and doing the right operations and right procedure. So what we will do, we will first find the LCM of this equation and this equation independently, then we will divide the two things. Okay, so moving on to the first one, 2 over, okay, I did a mistake. It's corrected now. What's the LCM? Like I said, it's gonna be xy. It's gonna be 3y plus 2x, right? Right. So now I know in my line above it's gonna be 3y plus 2x divided by xy, right? In my okay, let's continue. I was talking to my wife. Okay, let's continue. I need to cut this part. Okay. We're going to denominator. It's gonna be x and y square. And it's gonna be 5y squared minus y squared will be cancelled, so it's gonna be 6x. So in the denominator it should be 5y squared minus 6x divided by xy squared. Now I have my own tricky part that I imagine here, right? So I convert it to another form, 2y plus 2x divided by xy. I can say it means divided by 5y squared minus 6x divided by xy squared. I'm gonna move here. after this. So to change this into multiplication, we do a trick here. Y plus 2x xy. Now it's the denominator becomes numerator and numerator becomes denominator. This is the basic maths. So it's gonna be xy squared divided by 5xy minus 6x. Right? Right. The next step is this x gets cancelled. This gets cancelled. So it's gonna be y into 2y, not 2y, 3y plus 2x divided by 5y squared minus 6x. This should be the answer. Oh yeah, indeed this is the answer. Alright, answer. So this was example number 7. Okay, we are getting close. We're getting close. 3 more to go. Holy shit. Oh yeah, I like this one. This is crazy as hell, and I like this one. I'm not going to write the full thing. Example 8, it says simplify 1 over. I do have these things. I don't know. Nope. Fixed it. Right. X plus h minus 1 over x. My x and h kind of look the same. And this whole thing is divided by h. Now, another trick that we can do is we write x plus h minus 1 over x divided by h. Right? To change it to multiplication, it's gonna be 1 over x plus h minus x multiplied by 1 over h. So we're gonna keep it like that for now. So let's do the LCM thing for this bit. It's gonna be x, right? It's gonna be x and x plus h, right? Yeah, right. Okay, the book has solved it differently. Let's hope the way I think it should be resolved does the same thing. So what we do here is we will put x and x plus h. Now when we divide it, we get x over here. When we divide it, do the same operation, we're gonna have x plus h over here. And don't forget 1 over h over here. Now this bit and this bit will cancel out, so it's gonna be plus h. No, it's gonna be not plus h, because I did a serious mistake here. Let me fix that. It's not gonna be h. Right? We will have x over here, then we will have a negative, then we will have x plus h over here, right? Now plus x minus h divided by x plus h into h. These two cancel each other out, so I get 1h x plus h into 1 over h. Now these two cancel out, which becomes minus 1 into x plus h. And yola, yep, this is the answer. Moving on.